Dear students, in last class I have explained a very important equations which is called equations of motion. Which are those three equations of motion which we derived? The first one, v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the uniform acceleration and t is the time. The second one which we derived is s is equal to ut plus half at square, where s is the displacement, u is the initial velocity, t is the time taken and a is uniform acceleration and t once again is the time. And third and the last important equation, v square is equal to u square plus 2as. Final velocity, which is v, initial velocity, a is the uniform acceleration and s is the displacement. Now based on this we have a few numericals to solve. So let us try these numericals one after the other. See the question statement, very simple, easy question from 2013. A car travels with the uniform velocity of 10 meter per second. So that is the initial velocity with which the car is traveling. So u is a 10 meter per second. The driver applies the brake and the car comes to rest. So this is the initial velocity, and when the driver applies the brake, the car comes to rest. The final velocity is 0. It's a given. The car comes to rest in 2 seconds, in a time of 2 seconds. Calculate the retardation. So what is the retardation of the car? That's what we need to calculate. Now why they have given it as retardation? Because velocity decreases. When the velocity decreases, acceleration becomes a negative, and negative acceleration is called retardation, and that retardation we need to calculate. So which is the equation that relates v, u, a and t? It is the first equation, which is v is equal to u plus at. V is 0, u is 10 plus a to be calculated, and the value of t is 2. So bring 10 to the side, so it becomes minus 10 is equal to 2a, and therefore the value of a is minus 10 by 2, which is minus 5. Writing unit is important, which is minus 5 meter per second square. So this is the retardation. Very simple problem. This is not a 5 marks numerical. It's either a 2 mark or a 3 mark question. Okay. So hope you have understood. Very easy and simple. So let's go through statement of one more question. A car accelerates from 6 meter per second to 18 meter per second. So initial velocity is 6 meter per second. The final velocity is 18 meter per second, and it's given in a time of 12 seconds. Find the acceleration of the body. So find the acceleration. So again it's the similar type of problem. So where we need to find acceleration, initial, final and the time is given. So therefore the formula is the first equation of motion, which is v is equal to plus at. The value of v is 18, the value of u is 6, a to be calculated, the value of t is nothing but 12. So 18 minus 6 is equal to 12a. So this is 12 is equal to 12a. The value of a is 12 by 12, which is 1 meter per second square. So hope you are clear as how we can solve this kind of problem using the equations of motion. These are all easy problems. Okay. So let's go for the statement of the next question. So this question has appeared twice in the examination, and they may just change the data, the values. Okay. So therefore the type of the problem remains the same. The statement goes like this: a car moving along a straight highway with a speed of 126 km per hour. So initial speed is 126 km per hour. Is brought to stop. So finally the car is brought to stop. So final velocity is 0 within a distance of 200 meter. So here the speed is given in kilometer per hour. Kilometer. Here the distance is given in meters. So there is a need to convert this kilometer per hour to meter per second. So how to do that? This conversion part we have learnt in our the bridge course, where you need to multiply by 5 by 18. Correct? You need to multiply by 5 by 18. So, if you divide 126 into 5 divided by 18, you will get a value of exactly 35. So, that means this is 18, 7s are 126, you will get 35. 35 what? Meter per second. So, why 5 by 18? 5 by 18. So, one is a kilometer, you have to convert into meter, which is 1000, and divide by hour, and 1 hour is 3600 seconds. So, when you do that, you will get this 5 by 18. So all this explanation I have given under the bridge codes, right. So, S is equal to 200 meter, and initial velocity, final velocity is given, displacement is given. Let us see what to calculate. What is the retardation of the car? So, we have to find the value of A. What is the retardation of the car? And then, how long does it take for the car to stop? How long it takes means we have to calculate the time after which it stops. Now, here when U, V and S is given, time is not given. So, when time is not given, we cannot use a V is equal to U plus AT. We cannot use S is equal to UT plus half AT square. So, that means we have to use the third equation, which is V square is equal to U square plus 2AS. The value V, final velocity is 0. Initial velocity is 35 square of it plus 2 into acceleration is to be calculated into the displacement is 200. So, 35 square is 1225, and bring this to the left, that becomes minus, and 200 into 2 is 400 A. So, therefore, the value of A is minus 1225 divided by 400. So, 1225 divided by 400 will give you minus 3.0625. We are calculating the acceleration, so meter per second square. Now, there is a need to find the time. Now, once we know the acceleration, it is very easy to find the time using V is equal to U plus 8. The value of V is 0, the value of U is 35. A is minus here, you have to substitute minus 3.0625 minus 3.0625 into T. So, bring this to the left, 3.0625 T is equal to 35, therefore, the value for T is 35 divided by 3.0625. So, let us divide that. So, it is 35 divided by 3.0625, and we get 11.43. 11.43. It is a time that we are calculating, so that will be in second. Okay. So, in this problem, they have asked two options, one acceleration, and we have even find the value of the time t. Okay. So, hope you have again understood the important question that has appeared twice in the examination. So, let us go through one more statement, one more problem. A body with the initial velocity 83 meter per second. So, initial velocity, always write the symbol, proper symbol, 83 meter per second, moves under a constant retardation of 3 meter per second square. So, it is already given retardation. So, that is why you have to write minus 3 meter per second square. Okay. Find the velocity after 2 seconds. So, you have to find what is the velocity after 2 seconds. So, that is the first option. So, we can find V is equal to U plus 80. To find the final velocity in a time, I will use V is equal to U plus 80. What is the value of U? 83 minus, that is because of this, minus 3 into T is a 2. So, that is 83 minus 6. So, that will be 77 meter per second. So, that is the first option which is asked, find the velocity after 2 seconds. Then time after which it will stop. So the second option is you have to find the time after which the body stops. That means the final velocity has to be 0. So again we can use the same equation, v is equal to plus at. The value v is 0, the value u is 83 minus the value v is 3, and then we have to find the time. So bring this 3t to the left, 3t is equal to 83, the value of t is 83 by 3. So we can divide this, 3 2s are 6, then 23 here, 3 7s are 21, again 22 remains, so 20 there, then 3 6 are 18, and again 2 remains, 20, 3 6 are 18, so it's a 27.66 second. So this is the time after which the body stops, okay, time after which it will stop, and distance it will travel before coming to rest. So this is the third option, we have to find the distance travel before it comes to rest, and we know the time, in which it comes to rest. T is equal to 27.66 seconds. We have found the time in which it comes to rest. So how to find S? When we know the value of t, when we know the value of acceleration, when we know the value of u. So I can use S is equal to, it's ut plus half a t square. What is the value of u? The value of u is 83 into the time is 27.66, then minus half, that minus because of this, a acceleration, minus half into a is 3 into 3 into the value of t is 27.66 the square. Okay, so let's simplify part by part. Here it's the first part is 83 into 27.66, which is 2295 minus, so we have 27.66 square into 27.66 into 3 then divide by 2. So we are getting 1147 minus 1147. So we need to subtract this. So it's 2295 minus 1147, which is 1148 meter. So this is the distance traveled before it comes to rest. So you should know again properly as which equation to use based on the data. Here we have to find v in a given time. That's why it is v is equal to plus at. Here we have to find t when we know the value of v, correct? Here we know t, we are finding v, it's exactly opposite. Then they have asked a distance in a given time. So distance in a given time, we can find it using S is equal to ut plus half at square only, okay? Right. So this is one more numerical which we have solved, and these all numericals are important. So that's why unless you practice, you cannot solve these questions, okay? The next one, the equations of motion of a body is given by S is equal to 0.5t plus 0.08t square. What is the acceleration of the body? Equation is given, S is equal to 0.5t plus 0.08t square. So this equation is of the form S is equal to ut plus half at square. It's of the same format, right? So when you compare, what is the value of u? The value of u is 0.5 meter per second, the value of u. But we wanted acceleration, so compare here. Half a is equal to 0.08. Half a is 0.08. So therefore, the value of a, multiply here. So a is equal to, when multiply, you will get 0.16 meter per second square. is equal to 0.16. Just when you multiply, you will get 8 into 2, you get 0.16 meter per second square. Okay. So, hope you have understood. Again, one more type of problem. So, let us learn some more theory now. So, I am going to consider Earth. So, this is the surface of the Earth. Then I am going to consider an object here, like this. Okay. Okay. This object. Here it is, right. And if I release this object, correct? If I release, it will fall. Right. Now, if I take this object and then if I push this upward, okay, if I push it, just give a push up like this, it will goes up and then it will fall back to the earth, correct. And when it falls freely, it has uniform acceleration, and even when it is thrown upward and then again it falls back, it has uniform acceleration, and that acceleration is called acceleration due to gravity. So, that is what we are going to learn about the concept acceleration due to gravity. Now, what is the symbol used for that acceleration due to gravity? The symbol used for that is G. G is the symbol used. Okay. So, let me write that here. So, G is the symbol used for that acceleration, small letter g. Then what is the mathematical formula for this g? So, this g is given by g, capital Gm by r square. This is the formula. What is capital G? Capital G is called gravitational constant. What is m? M is the mass of the earth. Mass of the earth. What is r? It is the radius of the earth. Radius of earth. So, mass of the earth here, it is again nearly 6.7 in 10 to the power 24. The radius of the earth is 6,400 kilometer. The value of acceleration due to gravity is of the order of 6.67 in 10 to the power minus 11 SI units. So, these are all constant value. G is a constant, M is a constant, R is a constant, correct? And when you substitute this, all that value, we will get the average value of G to be equal to 9.8 meter per second square. So, that is how we get the value of G by substituting gravitational constant, the mass of the earth and the radius of the earth. The variation due to shape of the earth. Due to the shape of the earth, G varies from place to place slightly. So, that is why this is the average value of the acceleration due to gravity, because G depends on the radius of the earth, and the radius of the earth is not same, it slightly varies because of the shape. It is not a perfect sphere, and that is why G slightly varies from place to place, and the average value is taken to be equal to 9.8 meter per second square. Variation with the altitude. As we go above the surface of the earth, the acceleration due to gravity again decreases. So, G is a maximum on the surface of the earth. As we go up, the acceleration due to gravity decreases. Not only that, as we go inside the earth, as we go deeper into the earth, also acceleration due to gravity decreases, and then finally it becomes 0. At the center of the earth, the acceleration due to gravity is 0. So, which concludes that the acceleration due to gravity is a maximum on the surface of the earth, and as we go above, it decreases. As we go inside the earth, also it decreases. So, average value of the G on the earth I have already given, which is to be equal to 9.8 meter per second square, and sometimes for easy calculation they will give the value of G to be equal to 10 meter per second square. So, let us again consider a situation where we have the surface of the earth, and then we have now two bodies, okay, of different masses. So, here it is, one lesser mass and the other is heavier mass. Okay. When both the bodies are released together, okay, if I remove my hand, it will fall to the earth and it will reach the earth simultaneously. Both. That means the conclusion is that acceleration due to gravity is independent of the mass. It doesn't depend on the mass. G is independent of the mass. You take a heavier object and a lighter object, okay, and when allowed, they reach the ground simultaneously. But there is a problem. The problem is, if there is some air resistance, okay, opposition, then the lighter object will fall slowly. It will not reach simultaneously in the presence of the opposition, in the presence of the air resistance, okay. So let's see that later. Now let's go through the motion of a body under gravity. Whenever a body moves under the action of the gravity, and if it is a freely falling body. So what are the data that we can use? For free fall, initial velocity is always 0. See, if I take an object and then if I allow to drop it, correct. Okay, so this is the object, and if I allow, what is its velocity? It's a 0 right now, correct. So that is the initial velocity, which is always 0. U is 0. So we can always use this data while solving the problem. When we solve a problem based on the free fall, I can always write U is equal to 0. Then S is equal to H. What is S? Displacement. What is H? Height from the ground where the body is falling. So displacement is height from which the body is released, is always taken as a S, okay. Then what is the value of acceleration? Acceleration is always positive, plus g we can take. Why? Because velocity is increasing, so acceleration has to be positive, and the time of fall is called as a time of descent. It's going down, descending. That's why it is called the time of descent. So these are the data which we can straight away use while solving the problem. That is, for freely falling body, initial velocity is 0, displacement is equal to the height from which the body is dropped. Acceleration is always acceleration due to gravity, which is a positive, and the time of descent is the time taken by the body to reach the ground. How about for a body which is thrown vertically upward? When a body is thrown vertically upward, so when a body is thrown vertical, this is the body, and when it is thrown vertically upward, it has certain initial velocity, only then it will go up, correct? So therefore now this time initial velocity is not 0, even though right now it's a 0 when it is on my hand. Moment I release that from the hand, whatever the velocity with which it is thrown upward, and that will be the initial velocity, correct? And as you get noticed here, correct, when it reaches the maximum height, again its velocity becomes 0. That's why again it falls back. So that's why we take the final velocity as 0. Here initial velocity is 0, there final velocity is 0. Hope you understood. Then S, what is the displacement? Displacement is the maximum height to which the body rises. That is the displacement, S. What is the value of acceleration? It is always minus g. Here it is plus g, there it is minus g. Why? Because while falling, velocity increases, acceleration is positive, whereas while throwing upward, velocity decreases. So that's how acceleration becomes negative. So that's why we have to consider always minus g when thrown upward. And since it is going up, it's ascending. So that's why T suffix A. Time of ascent and time of descent, they are always equal. So these two timing are equal. Okay. If a body takes a 2 seconds to go up and again to come back to the same point, again it takes same time. A body is thrown upward, it falls back to my hand again after 10 seconds. So what is the time of ascent or time of descent? It is 5 seconds each. So 5 seconds to go up and 5 seconds to come back. So total is 10 seconds. So hope you have understood these data, and which we are going to use while solving the numericals. Okay. A heavy metal ball and a feather are dropped from the same height. Under what condition both reach the ground simultaneously? A heavy metal ball and a feather are dropped from the same height. Under what condition both reach the ground simultaneously? See, if it is dropped as it is when there is air, then they don't reach simultaneously. they will reach simultaneously only if they are present when there is no air, or what we call vacuum. Only in vacuum both heavy metal ball and the feather, they reach simultaneously. Okay. See here, you can see this is the drop of water. Okay. And then the feather, see, they don't fall simultaneously. The feather will fall slowly, correct? Whereas the drop of water falls faster. Why it is falling slowly? Because of the air resistance. Correct? They don't reach simultaneously. When do they reach simultaneously? Only if there is a vacuum. And the experiment was conducted in a vacuum where they dropped a heavy metal ball and a feather. Okay, look at this. So this is the feather and the metal ball dropped. See, they reached the ground simultaneously. So this is the experiment. So first they removed in a chamber, they removed all the air out of it with the help of high pressure pump, and then they dropped the metal ball and the feather. Look at, now they are reaching simultaneously. So if it is air, they don't reach simultaneously, but in the absence of air, as you can see, a very beautiful, wonderful experiment in which they reach the ground simultaneously. Okay. So hope you have understood about the acceleration due to gravity, and I'm going to solve problems based on this concept in the next class. So till then, take good care of yourself, and we are almost at the end of this chapter, student, and soon we are going to conduct a test in this particular chapter, and I am going to announce the date and start preparing. So there will be a test soon. It is just like the first test that was conducted, and I am going to conduct that on one of the Sunday. So hopefully on the coming Sunday I am going to conduct the test in this particular chapter. So I will inform you at the earliest. Thank you.